Good day, gang. Welcome to Section 6, Process Safety. When I was trying to figure out how I was going to deliver this, so I've been teaching this for, I don't know, several years now, and when I teach it, we're always talking about these huge events, the Deepwater Horizon, the Exxon Valdez, the Amoco Cadiz, all these huge events where just catastrophe, and havoc just prevails. So, but when I teach that, people go, how does this relate to me? Sure, you get your bow ties and your ALARP and hazard effective management process and all that stuff, and sure, that's lovely, but I'm a crew member. How's that going to affect me? It doesn't really. That's all captain and superintendent and senior management kind of stuff to prevent all those big, huge events from happening, and it doesn't really relate to me as a crew member. And it does though. Okay. So part of my job is I go around and try to build teams and teach safety and culture and all this kind of stuff. And when I'm delivering process safety, people go, man, brutal. So I was at a conference, a 2-day conference in Doha in 2007, October 2007. Actually, this exact same presentation. And so all the oil majors are in Qatar. Exxon are there, Shell, BP, ConocoPhillips, all these guys. But ConocoPhillips does a great deal of teaching, and they go around to all the companies, say, look, bring in your superintendents, and we'll do a conference. And in this particular case, they did 2 days on process safety. And I was like, man, do I really want to go to this, Anyway, I went. And this guy, Bill Denny, delivered this. I think it's like 200 slides. I'm only going to give you 30, guys. Don't worry about it. I'll put the 200 in a PDF format so you can see it. But I want to talk to you about it. So the way he delivered it was in a way that to show your crew how they fit into the process safety, how they fit into the puzzle of what process safety is. And I thought it was a fabulous approach so that you could use it to teach, and also you're reinforcing everything that we've discussed in this whole course. So things like the top event, hazards, barriers of control, mitigating consequences, the top event, all of these terminologies are really going to come together in this one lecture. Okay, so I use process safety, this bow tie method here behind me. When I go in and have a toolbox talk with the engineering staff or the deck staff in the morning, I always pull this little blank document out and we discuss the jobs that we're going to do today in a bow tie method. One, it reaffirms hazards, controls, and permit to work, locked up for life, all that good stuff. But also, it shows the other side of the right-hand side of the bow tie, which we don't really talk about too much, and is usually more pertaining to PM system. So I'm hoping that in this particular lecture, I'm not going to give you as much background information as I've given you before in all the other lectures. The other lectures were all about giving you all this information and trying to put it all together. This, I'm just going to try to teach you how to teach it, really. That's what I'm going to try to get. And because you already know all the fundamentals that go in all the different parts, now I want you to show you how to convey that information to a safety officer's in a safety officer's meeting, or convey it to your crew or senior management. And we use it a lot just as one. Now all of a sudden, everyone on board, from the captain to the mess man, understands the whole process safety model, so that they know when I'm doing this particular job, that is part of the process. This is important because when something goes wrong, this mitigates that consequence, or this barrier control prevents me from getting injured. And we just use this as a speaking point or a focal point to make sure everyone is aware of all the terminology, the concept of safety. And that is the strength, I think, of the way this particular lecture is delivered. And really, I hope you enjoy it. There we go. Let's get started. So we're going to start off with a little film that I show in the beginning of each one of these lectures. I'm not a big fan of it, but it does touch on a few points that I want to get across. So here we go.
Most people think process safety is about following a process, like rules and procedures to keep you safe.
That's a part of it, but not all of it. So what is process safety?
Process safety is about using special precautions to keep our facilities safe and our products in the pipes. In the process safety world, we call these special precautions barriers.
We interface with barriers every day as we work to keep our people safe.
Let's take driving, for example. Think about rumble strips that have been designed into the roadway to help you keep your car in the lane, seat belts to keep you secured in the car, and vehicle maintenance to keep things running smoothly. These are all barriers working together to keep you safe on the road.
We also use barriers in the process safety world to help protect people and the environment. These barriers can be equipment, people, or process related, and the bigger the potential hazard, the more barriers we put in place.
In our operations, we're working with hydrocarbons, which can present serious risks. Our job is to ensure that we not only have a good number of barriers in place, but also that they are as effective as possible. We're doing our part to strengthen these barriers. Engineers are designing safer systems. Our operations personnel are effectively performing maintenance. Supervisors are stressing the importance of following procedures. And process safety experts are analyzing events and making sure that we learn from near misses.
It's all about making our barriers as strong as possible. So what can you do to strengthen the barriers that you control?
Talk to your supervisor or join the Global Process Safety Excellence NOE and help us keep it in the pipe, because process safety matters.
So what's the difference between process safety and personal safety? Now we're going to get into this bow tie method here now in a few more slides, but I want to kind of explain it a little bit now just to give you an overview. So personal safety is the left-hand side of the bow tie, and you're quite familiar with that. You're always trying to identify the hazards, put in the barriers or controls to stop the accident from actually happening. Okay, so personal safety we do very, very well as an industry. All right, we're always wearing our helmets, safety shoes, boiler suits, ear defenders, goggles, gloves, you name it. Okay, and there's not many times you'll find people going out on deck or in the engine room or in a refinery without wearing their PPE, because we're always trying to prevent the accident from happening. Okay, and that's what personal safety is about. All right, process safety still looks at all that, but they look at it from an operational point of view, from a process point of view. The process could be loading or discharging cargo. If you're on a refinery, you know, the actual refining of your materials. Navigating is a process. Okay, and I'll use loss of primary containment as my example because my slide is up here for that. So in your process safety, your loss of primary containment is your top event. You're always trying to prevent it, you know, using your barriers or controls, identifying your hazards. But if you lose your primary containment and you have an oil spill or whatever it is, the bow tie method looks at the mitigating barriers after the fact to contain it. So if you have an oil spill and it starts to get bigger and bigger and bigger and bigger, what kind of defenses, mitigating defenses, do you have in place to reduce the loss of primary containment, to reduce the consequences of it getting worse and worse and worse? Okay, so that's what the difference between process safety and personal safety is. When I try to explain it to my classes, personal safety is always the left-hand side of the bow tie, all right? And process, which we do the left-hand side quite well. We understand the left-hand side. It's, you know, it's good old Swiss cheese model and that kind of stuff. But if you do have the loss of primary containment or the accident or whatever it is, how does that escalate, and what kind of barriers do we have in place after the fact to stop it from becoming a catastrophic event? And the other side of it is the process safety. That's how I explain it. I don't know if it's 100% true, but it's a good way I find it's a good way to teach it, get the idea across. So why is process safety so important? All right. So I'll use my bow tie as an example. On this side of the bow tie, we're all talking about personal safety and stopping the event from happening. So all our defenses and barriers are in place. Okay. And it's not just about doing a job. It's not just because when you think of personal safety, people think of a specific job. Okay. So process is about the bigger picture. It's your open reporting, your housekeeping. It's everything we've discussed over the past 5 or 6 chapters. So how you run your installation, whether it's an oil rig, ship, or even your office. okay? All the processes that you do, okay? And when you're planning for a job or navigating or refining a product or loading a cargo, you can plan for that. And this side of the bow tie, you can take a lot of time to to make sure it doesn't happen, okay? Make sure you don't lose control, okay? Here on the other side, when you do lose control, when you have that leak and the leak comes in contact with a hot surface, then bam, this side of the bow tie escalates like that. It usually comes into an explosion. You know, Exxon Valdez hits a rock, bam, there's oil going everywhere. I'll use here in the bottom right-hand corner the Macondo for those of you for more recent. You know, the good old Deepwater Horizon down the Gulf of Mexico. Bam, it just happens, and then all of a sudden it is the biggest catastrophe, $20 billion. Oh my gosh, you know. So the problem with process safety is one serious process safety event can drastically impact a company's brand, their reputation, financially, as you can imagine. Share price can plummet. Public perception of not only the company but the industry as well gets reflected. So process safety is it's a big yeah. I can't get any more than that to it. All right, so that's why I have it in this particular section now. So it hopefully will bring everything that we have done together into really one little picture, and then we'll discuss it throughout this lecture. So these are some process safety events that happened in my company recently, and I want to talk to you about them because they're very good examples of different parts of process safety, which I want to touch on later on. All right, my first one up here is a vessel. We had a loaded tanker at Fujairah Anchorage, which is just outside the Persian Gulf, if you're not familiar with it, at anchor, fully loaded. And she was at anchor, and this was her along here. Another vessel was coming down this way, and then out of the blue, for whatever reason, the other ship decided to do a 90-degree turn and wham, and T-boned this vessel. Bulbous bow, as you can see, has gone through the side of the ship and a little bit of damage near the top. Okay. I was actually talking to one of the crew members who were on the starboard midship crane at the time. They were loading stores when this vessel was coming along, and poof, out of the blue, turned starboard, banged into us. Funnily enough, then, the ship pulled out of us, left a hole there, went down a little further, banged into another ship, went down a little further and banged into another ship, and then eventually came to anchor and stopped. Okay, and from what I understand, that captain is no longer allowed in the UAE waters, territorial waters anymore. Anyway, that's not the point. The point is, this is a liquefied natural gas carrier full of methane, and if you can imagine the cargo tank inside, and this is your water ballast tank, when the other vessel hit us, it went through the water ballast tank and stopped approximately 5 inches from the cargo tank. Okay, if you can imagine, LNG, if you're not familiar with it, is carried at minus 162 degrees Celsius, and a loss of primary containment there allows a freezing cold liquid to come out. It'll come in contact with mild steel. Everything will brittle and fracture, and also then release of the hydrocarbon itself. Explosion, catastrophic event. You get the picture. Okay. Luckily enough, it stopped here. I'm using this example because I'm using ship design as part of the process. Okay. When that ship was built, it was built and designed to withstand a Suezmax vessel hitting it T-boned at full speed. And guess what? A Suezmax T-boned us at full speed, and all that happened was the ballast tank took the brunt as per the specifications of the ship build. Okay, so that's a part of the process. It's not just PPE and toolbox talks and risk assessments and stuff like that. It's everything. It's ship design, regulations, and anyway, won't get into that. You get the general picture. The next one up here is good old Barcelona. This is not one of our ships, but it was carrying one of our cargoes. All right, so it is an interest to our company. So this particular ship was discharging in Barcelona. All right, so as they're discharging, the tank levels are decreasing, as you would expect. They're pumping the cargo ashore in the Barcelona holding tanks, and the ship was discharging, and all of a sudden the level was rising in number 1. No one really noticed it, but they got the high level alarm very, very, as they're starting off, and the chief mate goes, And this is the good old quick thinking brain starting right away. You don't know the answer, but then you automatically come up with a solution in your mind to justify your reason. Okay, so you're discharging, the levels should be going down. All of a sudden, the tank level is going up in number one because the loading valve is slowly passing. Okay, so the level is coming up. He gets an alarm in his tank number one. He goes, oh, must be a faulty alarm. We're discharging. Levels are going down, not going up. Doesn't give it a second thought. The level keeps coming up in his tanks, keeps coming up, fills the tank, and now starts coming up the forward vent riser. Okay, so it comes up the forward vent riser. Now liquid LNG, liquefied natural gas, is now pouring out onto the deck at minus 162. All the deck is now being frozen, fractured. You ever see those examples where the science guy takes a rose or a ball and puts it in liquid nitrogen or liquid oxygen? It freezes and he throws it against the wall and it shatters. Same idea now, except this is your forecastle. Okay, then as the liquid comes out to atmosphere, it automatically starts to boil, and as you can see here, the cloud, there's now a methane cloud enveloping the whole vessel. Can you imagine if one of the intrinsically safe lights were not stored properly, or someone was on deck with a phone, or any kind of an ignition source? The ship would be gone, let alone the ship, Barcelona would be gone. Okay, luckily enough, they shut down the system after running an emergency shutdown, stopped everything, and the cloud just dissipated naturally through the wind. Okay, but that could have been a huge incident. Okay, they didn't have to go to dry dock, repair all the steel up forward, and anyway, won't get into that. But I'm using that as an example of the process itself. You have alarms and set points for a reason, okay? And if you're not going to follow them or listen to them, and like I said, it's just guys going, oh, the tank level should be going down. It can't be going up. It can't be filling the tank. It's impossible. Well, there you go. So these are my examples to explain some of the theories we're going to be talking about when we talk about process safety. So my problem in the past, when I've been teaching process safety, you always talk about these big catastrophic events that that infrequently happen. They don't happen very often. Knock on wood, thank God, eh? So when I'm delivering that to crew members or even officers, they're like, man, what does this have to do with me? That's some big event that it's not really my day-to-day thing. I'm always concerned about my guys getting hurt. I'm always concerned about personal protective equipment, prevent accidents from happening, open reporting, making sure my risk assessments are good, my plant isolation is well established, my permits are in order, because those are the accidents that happen quite frequently, okay? And because of that, we as an industry, we put a huge amount of emphasis on personal safety because it happens quite frequently, and all those little small cuts, nicks, burns, bumps, you name it, okay? And process safety has always been pitched at this high level, catastrophic event, and trying to make it relevant to my crew, I found always quite difficult, okay? They kind of understand it, but really they're like, man, that's just something I'm going to forget as soon as you leave the room, Dave. So when I took this course in October from ConocoPhillips, they pitched it at a level where it shows everyone how they contribute to the process, okay? And even though the process itself doesn't fail very often because there's so many barriers and controls in place, okay, one barrier can fail, two barriers can fail, but eventually it will get caught by a barrier before the loss of containment or the top event happens and it all turns to shit, okay? So I'm hoping to, in my next couple of slides, show you now how process safety, how you pitch it to your guys, that it's not just some big infrequent event that happens every now and then and there's nothing you can do to it. This is showing you how you contribute to process safety, where you as an oiler, as a messman, to the captain, third engineer, all these things pertain to you, and these are the things that stop, okay, the catastrophic events and the consequences from getting worse and worse and worse, okay? So here we go with a few examples. So when I'm on board delivering these lectures and stuff like that, these are my 4 exercises that I use, and I break up the teams into 4 small teams. I don't have that luxury here online, So I'm only going to discuss the flange installation and torquing. The reason I use that more so for online here now is because really it's just a nut and bolt type of job, and everyone in my class here, no matter what your level of education or experience, you should have a rough idea of how to undo a few nuts and bolts and inspect inside this pipe. Okay. In my scenario here, though, this pipe is a hydrocarbon line, so it contains, we don't know what it contains, but there's hydrocarbons inside of it. Okay. So in my scenario, I always tell everyone it's a bunker line, a heated bunker line. So there is bunkers inside, fuel oil that is, I would say it's boiling or anything like that, but it's hot. If it comes in contact with your skin, it'll give you a little bit of a fright. Okay. So now we want to take that flange off and inspect it. Okay. And I'm going to use the bow tie method to explain to you that job and how the process of doing it is so important. Okay, so one, I want to teach you how to use the bow tie method, which is obviously the key objective here now. But two, when you take this now and start spreading the word and you know explaining it to your crew or your office or whatever you're doing with it, okay, I'm trying to get you to show you how it all your crew or all your staff are a piece of the puzzle of process safety, and it is not just some big catastrophic event that only management are concerned about. I want to show you how you fit into the puzzle, all right, or your crew fit into the puzzle, all right. So here we go, bow tie method. Let's get started. So this is our bow tie diagram, and it's called a bow tie diagram because of its shape. It looks like a bow tie, easy peasy. So when I teach, especially on the left-hand side of the bow tie diagram, I usually teach it like a risk assessment, and that's not 100% accurate, okay? Because a risk assessment is for a specific job, all right? And process safety is about the process of doing your job. So how can I explain it? I will try to clarify as I'm going along, all right? So when you're doing a bow tie for, let's say, this particular job, replacing that flange, taking the flange off and putting it back on, inspecting the pipe inside, all that good stuff. So there are some hazards associated with that job. And if I gave you 10 minutes in a group of 5 or 6 people and I told you identify the hazards, I'm sure you come up with a fairly extensive list. Okay, and same thing here. We talked about it in whatever chapter it was, about getting your experts involved, brainstorming ideas of all the hazards involved. So in this particular job of the replacing the flange, some of the hazards might be the weight of the actual flange itself, pressure in the line, the hot liquid. We said the bunker line was heated. Access to the actual site might be a problem. Pinch points when you're reattaching the flange or swinging the flange around. Inexperience is a hazard, for sure. Spillage, once you do crack that line, no matter how much you've drained it or whatever it is, you're still going to get some semblance of a leak. Incorrect tools, making sure you have the proper tools, your finger savers, 10-pound maul. You can never go wrong with a 10-pound maul when you're opening up a flange, and proper tools and stuff like that. The incorrect gasket and corrosion itself. Okay, these are all the hazards, and I could keep on going. Okay, and stuff like that. But I'm just using these to show you how the system works. Okay, and so like any risk assessment, you sit down as a group of people, brainstorm your hazards, and put them all down. And that's what we've done here now. Okay, so now in the Swiss cheese model, you want to put in barriers or controls in place to prevent those hazards from turning into an accident or an incident. Okay, and here they call it the top event. And some of the barriers we might talk about might be a chain hoist to help you lift the weight of the flange. Okay, things you might be looking for is making sure you're using proper strops, hanging off points are safe working load tested, chain hoist is in good working order, things like that. Okay, next is the good old permit to work system. You can't go wrong with the good old permit to work. It's not the piece of paper that makes you safe, let us be clear, but it's all the instructions on the permit to make sure you have them all done before you get voted for signatures. So that might involve, draining down the system, locking it out, making sure people understand what's going on. Anyway, we won't get into that. We've already talked about permit to work. Next is the toolbox talk. And when I travel around, I we focus so much on the toolbox talk because this is where everything comes together. This is where you've planned your job, you've assigned your people, your permit to work should be almost at the verge of being completed here now. Your plant isolation has already been discussed, your tools, your equipment, how you're going to do the job. I cannot stress to you enough a good sense of communication, participation in your toolbox talk to get yourselves all organized. I cannot stress to you enough is a really solid barrier. Okay. Next are your O2 checks itself for hydrocarbon vapors or toxic gases, whatever's involved. Okay. Next is isolation. You're not just going to open up that flange when it's under pressure. So draining it down properly, locking out your valve so nothing comes in after the fact when you open it up. All your isolations, that will tie in as well with your permit to work, as you can imagine. Okay. Next is proper tools. You're not going to use any homemade improvised tools, stuff like that. You want to have your proper torquing wrenches and all that good stuff, and in good working order as well. You know, cracked off handles and anyway, we won't get into that. But make sure you're using the proper tools. Experience. I cannot stress to you enough. When I talk about risk assessment, I always talk about the most inexperienced person on board your ship being assigned a task with base PPE, helmet, boiler suit, safety shoes, goggles, and gloves. Okay, so when we talk about PPE for a certain job, you're always talking about PPE above and beyond the basics, which is your helmet, boiler suit, safety shoes, and a pair of gloves and goggles. So same thing here for experience. Your most inexperienced person on board, if I assign them to do this job, of course they're going to get hurt. Okay, so when we talk about experience, we want someone who's done this job before, or supervisor, whatever it is. Okay. Next is the gasket itself, making sure you put the gasket in between the two flanges so that it doesn't get further leaks. So this is where process safety is more than just a risk assessment. Okay, it is how your process is done, and the process of replacing a flange or changing up this flange is that the proper gasket is used after the fact, tightening up your flange properly after the fact, all these things. So it's not just the good old hammering open the bolts and opening it up and make sure it's isolated. It's the whole thing of putting it all back together, and I'm going to show you how that comes together now in just a few minutes. The next, when you crack open the flange, you're going to get some form of liquid come out, no matter how much you've drained down. That liquid, if it fell on the floor, could become a slippery surface and create another hazard in itself. So a drip tray to catch all the drippings or drainage at the flange itself when you crack it open. And of course, tools. Okay. And last but not least, defense is always PPE. And really, you should not need PPE if all these other things are done. Like I said, in the hierarchy of controls, the last level of defense is the PPE. So you may want to have a face guard when you're cracking open the flange, maybe some type of impact gloves for when you're using the hammer and the spanner to open up your things. Maybe certain types of gloves itself, impact gloves when you're putting the flange back on. And it could be anything. All right. So please keep that in mind, that PPE is the last line of defense. So if I go through all these barriers or controls and they're all in place, 99.9% of the time, you are not going to have an accident. You've had a good solid toolbox talk, your permit to work, your plant isolation's in place, you have experienced people, proper tools, good PPE, O2 checks for all these different things, and you're not lifting it using a chain hoist. It's a really solid, well-planned job. Okay? But in my example for process safety now, let us say that we had a relatively inexperienced person, okay, and he installed the wrong gasket, as my example, okay? No one got hurt. No, you didn't lose primary containment at the time. You've put the flange back on. You've pressure tested it up. There's no leaks, okay? That's fine. Everything works as it should. But you have put in the wrong gasket, and maybe not today, maybe not tomorrow, maybe next week, you start to get a little bit of a drip, okay? And this is what we're going to be talking about now when we talk about process safety. So I'm going to pause you right here, and I'm going to move on to my next set of slides for this. So now we're on the right-hand side of the bow tie, and this is about the mitigation barriers. And what I mean by that is, it starts off here we talk about all the hazards to stop the one single event from happening. But if it does happen, this is what the difference between process safety and risk assessment is a little bit different. At risk assessment, you're always talking about just stopping the event from happening. But in process, what if it does happen? Okay, you lose that primary containment, and then how does that get bigger and bigger and bigger and bigger and bigger until the outcomes, so the consequences get more severe. Okay, so we talked about the gasket being put in improperly, or sorry, the wrong type of gasket being put in, and an inexperienced person doing it. Okay, so the job itself, no one got hurt. There was no leakage during the pressure test of the line. Everything's working well. And like I said, the leak hasn't started today. It might not start tomorrow, but in a week or two, or maybe even in 6 months from now, the gasket deteriorates and you start to get a small leak. That's all it is, just a drip. Okay. Now, what are our first things that we have on board to detect that leak? Okay, just think about that for a second. Most people go with leak detection and stuff like that, but your first thing is rounds. Okay, whether you're working cargo, doing your deck rounds, or your duty engineer doing rounds of your engine room, going around looking for those leaks. So when I'm having a daily work plan or at a daily work plan meeting and all the open reporting is coming in and stuff like that, and another one is also open reporting. And all these small things that people are putting in as hazards, okay, leaks, poor housekeeping, stuff like that. These are the quintessential, these are the essential first steps of finding things before they turn into something worse. Okay, that's why maintenance, good housekeeping, whatever you want to call it. Okay, if you have that, and with all that in your policies and procedures, okay, that is the first step. If you catch it at your rounds level or your open reporting where it's just a leak, then that's it. You've caught it. You've tightened up the flange. Maybe you have to you don't understand the leak is still there. You might take it all apart again, open it up, find out the gasket is the wrong type, put in the proper type of gasket, seal it up, and it never ever becomes an incident. Okay, so when we talk about open reporting, I know in chapter, I think it was 2 or 3, I was talking about it. So important. If you got, I don't know, 20 or 30 guys on a ship, and you got 30 guys looking for things that are going wrong on your ship or your installation, whatever you want to call it, and you catch it at this stage, then poof, it never ever becomes this catastrophic event. Okay, so let's say you got people don't really give a shit. They see the leak, they just assume that it's you're in an engine room, of course it's going to leak. They just accept it because the standards are so low. Okay, same with open reporting. They walk by, it's like, that's not safety, that's just housekeeping. Everything leaks here. That's how it goes. So now let's say all of a sudden your leak, your flange, your gasket deteriorates even more, and in the middle of the night, now your leak turns into a spray and it starts to, drip, pour in liquid into your bilges of your ship. What are the detection types of stuff do you have? Okay, and the next is your bilge alarms. If your float comes up, you got hydrocarbons pouring into your bilges. That bilge alarm goes off, sends off an alarm in the middle of the night. Someone comes down and investigates, and they find the leak. Okay, but I talk to the machinists and stuff like that. Every Saturday or whatever weekend test you do, you run down and test the bilge alarms. And some guys, man, why am I testing this every freaking week? And then they start cutting corners, or they rig up some kind of way to jury rig the stuff so they don't have to test it, and they still get their noises. We won't get into that. That's just bad practice. I'm not teaching you that. Okay, but the alarms themselves are the first level of finding things before they go wrong. Okay. Same thing. Let's say my leak has turned into a spray. It hits onto a small hot pipe. It starts to smolder. Smoke picks it up. They set it off. Someone goes down and checks, and they catch it before it turns into a fire. Okay. And then automatic systems. Sometimes you'll have heads which are they see flame. The flame detectors. And as soon as you get a small smoke turns into flame, it hasn't been caught, and poof. Automatic systems. It sounds off the alarm, shuts in dampers and stuff like that. But if you're doing your PMs and you're not doing these things, your automatic fire dampers are seized. You're not doing your maintenance for that. Your smoke detection, you're not regularly checking it. It's not detecting properly. You're not testing your bilge alarms. All these things. And at 2 o'clock in the morning now, all of a sudden you have oil pouring out of this gasket. It's hit a hot pipe. It's turned into a fire. your gas heads and your smoke heads are not working. Now all of a sudden, that small fire has turned into something rather raging. Okay? What's your next level to prevent it from getting worse and worse and worse? And as you can see, the bow tie is getting bigger and bigger and bigger. Okay? So the next level of defenses you have are your stops, your fuel stops and stuff like that. Your fixed firefighting system, depending on how big this fire has gotten. Procedures for shutting in and isolating equipment. All right? And possibly assistance from outside. You might need to get tugs. You might need to get with fire capabilities. You might have lost the engine. You might be drifting. There's all kinds of different scenarios here. Okay? But you don't catch the fire in the middle of the night. People are not experienced. Your fire flaps aren't, you haven't done your work, your PMs on it, they're not working. Your fire detection system you were getting alarms, so therefore you've isolated it, you blocked alarms or whatever it is, and you're not familiar with the procedures. And now all of a sudden, this fire, all of a sudden, is starting to really rage, and you're going to lose your engine room. Okay? Once you start losing your engine room, okay, then you got to get people in there fighting fire. All your drills, your practices, your SCBA, your breathing apparatuses, all your hose handling drills, that comes into a force right now, okay? You're trying to get in there and fight that fire. But if you're not doing drills properly, same thing, every defense has problems with it. You're not doing your drills properly, that turns out to be an absolute mess, okay? Next stage, you've lost the engine room, and all of a sudden you got to abandon your ship. It was the best lifeboat in the whole wide world until you have a fire, and now you have to abandon ship. Your lifeboat drills, all that kind of stuff. You're thinking, oh my God, it's Saturday again. Why am I testing the engine? Why? I just tested this last week. Why do I have to swing this boat out every week? And all these things. Because the right-hand side of the bow tie, once it happens like that. Okay? The left-hand side, you could plan to replace this gasket and flange for hours, maybe even days, depending on how complex it is. Okay, you have tons of time on the left-hand side of the bow tie, but as soon as you start losing that primary containment, and poof, it hits starts to leak, then it hits a pipe, then it turns into a fire. You haven't got a defense in place. The fire gets bigger. Bam, 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 and all of a sudden you're going to lifeboats. Okay, other things to think of is communication, how to send off distress messages, EPIRBs. And when your boat sinks, okay, it escalates very, very quickly. So when we're talking about the process, this is where I try to show the machinists, the ABs, where they fit in place, doing their rounds, open reporting. If we get that part right alone, okay, then it never escalates past just being a leak. Okay, does that make sense? Fixing all your things, making sure your smoke heads work, testing all your stuff, checking your lifeboats, so forth and so on. These have to be working 100% all the time, because if God forbid something does happen, you don't get a chance to think about putting a motor on your fast rescue boat to put someone in. It should be ready to go now. Okay? Same with your gas heads. Press the button, your vent flaps shut. Okay? Close your doors, poof, press the button, the CO2 is released. Everything should work, because if it doesn't, it escalates very, very quickly. Okay, and this is the bow tie method. All right. So that's my description of the bow tie method. All right, and I'm aware that I teach the left-hand side of the bow tie kind of like a risk assessment, and I probably shouldn't. Okay, because the risk assessment, like any other barrier, your PPE, your toolbox talk, your permit to work system, your risk assessment is part of your process, is part of the process safety. Okay. And I teach it because, we talk about brainstorming your hazards, putting your barriers in place, which is very, very similar to the risk assessment, okay? But it is in a bigger scheme of things. That's why I demonstrate the gasket, okay? In a risk assessment, you don't put the gasket in, because of whatever it is, because that is a process. It is good housekeeping, good seamanship to use the proper or good engineering practice to make sure the proper gasket is in, okay? So here, in my next couple of slides, is just to review a few things to show you the difference between personal safety and understanding the left-hand side of the triangle, left-hand side of the bow tie is not a risk assessment. It is all the barriers which are part of your process, okay? So when I talk about the flange installation and torquing here, the body in the line of fire, okay, if you're going to crack open that flange, your body position. You don't want to be standing perpendicular to it, so if anything comes out of the flange, it hits you. You want to be standing out of the line of fire. Lack of PPE, not wearing your visors or not wearing a special pair of gloves or whatever it is. So when you do crack that flange, something comes out and hits you. Also, PPE is your personal O2 meter. So if anything comes out there that's toxic or fumes, you can evacuate the space. Okay? Bad ergonomics, access to the site, lifting heavy objects, all these things. Hydraulic leak causing injury. So if anything squirts out of the flange or that hydraulic hose that the guy is using for his nut gun there, that hose breaks, hydraulic thing breaks and catches you. All right. Improper bolting tools. All right. You got some kind of homemade tool, or you put a 3-foot pipe on the end of a small spanner to get your extra leverage. That kind of stuff is just an accident waiting to happen. Okay. And we try to emphasize that when we talk about the risk assessments, toolbox talks, and making sure you have all your proper tools and stuff. The process side of it includes all that as well. Don't get me wrong, it does include that. But also things like the incorrect torquing of bolts. So there is a procedure, a technique for properly torquing bolts so that you don't get one side more tight than the other, then causing misalignment. Okay? Using incorrect torquing tools. So using a torque wrench that gives you more torque or not enough, or using a wrench that's not a torque wrench, getting a 10-pound hammer, putting a pipe on the end of your spanner and beating the living daylights out of it. Okay, that's not part of your process. I can sure it's not in the SMS for recommended ways to work. Okay, incompatible bolt and flange material. Okay, everyone goes, oh, stainless steel bolts are awesome, and sure they are. They don't corrode themselves, but they don't stretch, or when they break, they just snap. They break. Okay, and not only that, but then you have dissimilar metals. So the softer iron will corrode faster than the stainless steel, because obviously the stainless steel doesn't. And usually the corrosion takes place inside the flange, inside the pipe, so you don't see it. So then that threat becomes corrosion from the inside, which you can't even see. Next one is incorrect selecting of the gasket or on the process for the process service. So like I said, putting in the wrong gasket, there's no risk assessment or toolbox talk that really covers that kind of stuff. But it could be mentioned in the toolbox talk using the proper gasket material. But if it's missed and you get an inexperienced person that pops it in, and it's really not covered in a risk assessment, okay? It is a process of your work. This type of flange requires this type of gasket, okay? And loss of containment due to flange misalignment, all right? I remember going to my engine rooms nowadays, and they have this great chart of why things misalign. Do the pipes not go together this way? Do you tighten too much on one side? It bends it like this. There's all kinds of things. There's a process for making sure your flange aligns. And you torquing the living daylights out of it and pulling it together is not best practice, okay? And that is a process that you have to examine as well, all right? So the whole thing of putting it together, it's a combination of all your barriers or controls to prevent the accident from happening or the incident from happening, but also the mitigation after the fact. If you do get a leak, okay, what happens, how to prevent that kind of stuff. And it is your process, open reporting, rounds, checking all your sensors, making sure your alarms are tested, make sure your lifeboats are ready. All of these things, all of these defenses in place. And then it looks at your whole system, your whole process, without, it's just a great model to use. Anyway, guys, let's look at the next couple, and and that'll be it. All right, so I'm going to skip over the cutting and grinding, cold cutting. It's very, very similar to the welding example I'm going to give now in just a few moments. I'm going to look at scaffolding here. And when I deliver this to people, I'm usually delivering it to mostly seafarers, okay? And one, I want them to understand how important they are and how well trained they are as well when I'm giving this lecture, because it is. Part of my job is to build teams on board and stuff like that. Okay, so they are a paid mariner. So a seafarer these days, they are a jack of all trades, master of none. They can be in the engine room overhauling engine, lifting operations, loading cargo, security watch on the gangway, navigation. You name it. There's not much that we do welding, fabrication, you name it. We are a well-rounded bunch of people, okay? And with that, we understand the hazards of different types of jobs because we do many different types of jobs, okay? When you go into dry dock, though, you have usually a very, very well-defined skill set. Someone is a scaffolder, a welder, or a grinder, or a pipe fitter, okay? And if I go in and tell some guy to rig up scaffolding, sure, they go in, they know how to do it very well, poof, they will erect a scaffolding, okay? But do they have the understanding of other things, simultaneous operations that are going around or hazards around them that this scaffolding rig up is going to affect, okay? Sure, we look at the personal safety. Everyone knows it because it's inbred in the industry. You know, everyone, okay? You're going to rig up scaffolding. First thing you're thinking of is, is your safety harness, detachment points, lifelines, all right? Dropped objects, all these things, okay? Injuries caused to pinch points. You're swinging around pieces of pipe and things like that. God forbid scaffolding collapse. We always go out and check with our scaff tags, checking the rigging, make sure it's all done properly and approved. I do a lot of work in the Persian Gulf, Singapore, with a lot of humidity and stuff like that. Heat exhaustion is another concern of ours from a personal safety point of view. Okay. The process safety point of view, you got a tradesperson who knows his trade very, very well. Okay. And if I told him to rig up scaffolding, bam, it's done. Okay. But do they consider or question where we tell them to rig it up, or someone tells them to put it up? Are they blocking deluge nozzles or fire or gas heads when they rig this up, which is part of our process? They have to be, usable to detect. Okay, increased congestion. All right. So when you're rigging up a dry dock, everything comes on board. Generators, toilets, all the other gear that they're bringing on, scaffolding, extra lines, power cables, so forth and so on. Okay. And if you're going to rig up scaffolding, does that create a pressure zone? If something blew up here, would that, bam, go off in a different direction? Okay, things to think about. Also, escape routes. I tell a guy to rig up scaffolding. Yeah, sure, no problem. I'll rig up scaffolding. Bam, that's my job. Done, sorted. But he might block your walkways. He might block a door. He might block access. I was on a rig once where they rigged up scaffolding and they blocked off the entire fire control manifold. You couldn't access it. So God forbid we had a fire in the middle of the night. No one could access any points of the fire control station because you had to climb in through a series of pipes and boards from the scaffolders. Okay, so that had to be taken down, as you can imagine. Close proximity to vents. All right, so if you can imagine you're pressurizing your system, the vent goes off near a scaffolding and blows someone off or collapses the scaffolding system. Loss of containment due to dropped objects. I was on an oil rig once in a dry dock, and we had lost a scaffolding pole. Someone kicked it off the side of the main deck, so it wasn't even considered a dropped object because it's on the deck, but it fell over the side into the dry dock. So 60 meters, give or take. When it fell down, it hit the dock bottom. It dug in almost 12 inches. We had to get a jackhammer to take it out. All right. Can you imagine if you're working on some kind of scaffolding, something falls and hits a pressurized line, or falls into a bunker tank or a cargo tank that could be full of hydrocarbons or whatever it is? Do these guys understand that? I would say more than likely no. Okay. So the process of you going out and checking that's the kind of stuff you're thinking of. The right-hand side of the bow tie of fire detection, nozzles, escape routes, all these things. How's it going to damage cargo? How's it going to operate? How are events go off? What's going to happen here? It's a lot of stuff to be thinking about, all right? And we're just trying to bring it to the foreground when we're talking about process safety. Our next example is welding, okay? Same thing here. All the left-hand side for welding, inadequate permits, potential industry hygiene exposure to fumes, falling from heights, lack of PPE, inadequate platform or scaffolding. I'll tell you a few little stories for this, actually. Lack of PPE. I had a buddy of mine, chief engineer, just down 2 doors down from me. He was in charge of building 3 oil rigs in China in a dry dock. And we talk about lack of PPE. So welders in that particular dry dock were not issued welder's goggles. Okay, they all welded naked eye until their eyes failed, because there's another 250,000 welders in line for the job. Okay, cheaper to get new welders than pay for the actual glasses. All right, it's a horrible story. I shouldn't even laugh. But his job was to not let anyone die during his month on board, month on, month off. And if anyone died during his month on, you got a bonus. Okay. It was crazy. So things like I said, things falling from height, all those things we talk about, because we do that quite well when we talk about personal safety. We know the intrinsic hazards of welding. But from a process safety point of view, okay, incorrect isolations. Are you going to weld into a hot pipe, as in there's hydrocarbons in it, or you're welding onto a wall or a bunker tank, and on the other side is a hydrocarbon, or whatever it is, okay? Or the line itself might be empty, but it could have vapor left in it enough to catch on fire, okay? It hasn't been purged properly, drained properly. Flammable gases near atmospheric vents. So your particular area you may be welding at, but there could be a vent down the way that could be expelling gas, and that could be the source of you could be the source of ignition for that. Okay, so same thing. If you're in a dry dock, you have a welder on board, and he comes on board. Sure, he knows how to weld, no problem at all. You tell him to weld that, sure, and break up the gas axe. I'll cut that off, or I'll burn that, or join this, whatever it is. Okay, but are they aware of the simultaneous operations that are going on? Is there bunker operations going on over here? Is this doing here? So forth and so on. Are they using the correct welding rods? Okay. Inadequate purging of vessels and piping. I don't want to go into too many stories for that kind of stuff, but there's been many, many, many cases. One of my favorites is I had a buddy who was working in a terminal, and they were going out with they're going to replace a section of pipe on one of the lines. And it's been discussed, planned for weeks, and the guy gets out there and he puts his hand on the pipe. He says, man, there sounds like there's flow through this line. You know, something's not right here. I'm working on line 6, you know, and it doesn't feel right. And he calls up the boss. He said, look, before I cut into this line, you know, nothing, it doesn't seem like it's isolated like it should be, you know. And he goes, no, it is. Line 6, all good, you know, so forth and so on. And puts his hand and said, no way, man, that's a live line. There is flow in that line right now. I'm not going to cut that line. Anyway, he stopped the job. Other people came out, yada, yada, yada. They went and checked, and they saw, sure, the little tag on it was number 6. And the welder goes, what happened was there was a riveted on little bracket that said number 6, and one of the rivets were gone, and it flipped upside down. It was actually line number 9 that they were actually at, not line 6. It flipped over, and they were going to cut into a live line. And if it wasn't for the experience of this guy, right, he would have cut into a live line at a refinery, okay, a product refinery, into a product line. Can you freaking imagine the catastrophe? And all it was his experience, a bit of common sense that never did it, okay? Anyway, I'm using that as my example to make sure it's not just about cutting and preventing the injury of that one guy. Okay, and maybe that's probably the biggest difference between personal safety and process safety. Personal, you're looking after you or your buddy, or it's very, very narrow and focused. Process is, what happens if you screw up? How is it going to affect everyone else? Do you lose the rig? Do you blow up the ship? Do you catch on fire? Do you kill a bunch of people surrounding you? That is the kind of stuff you want to be thinking about in process safety. Anyway. There we go. I really enjoy this showing this slide. One, I like seeing everyone's puzzled face on it when I try to get them to look at it. If the black dots represent hazards, how many hazards do you see? And this is not a video, it's an actual optical illusion. And if you focus on one intersection, you'll see a center white dot, and the black move around. And as you move your eyes, the black dots at the intersections move as your eyes move around the screen. The reason I show this is because hazards are as fluid as this picture, as in at certain stages your hazards might be present, they might go away for a while, and they might reappear in your job or your focus that you're doing. Okay, I'll use the replacing of the gasket, the opening of the flange in my earlier scenario. Let's say you've isolated well, and when you crack open the flange, the hazard of something flying out from residual pressure might be there, and poof, it comes out. But once you've separated the flange, then that pressure disappears and that hazard disappears. But if down the line your isolation is passing or completely fails or someone removes it, God forbid, and repressurizes the system while you're there. You think the hazard is not there, and then bam, all of a sudden it is there and you get injured. Okay, so please keep in mind, I use weather as an example, okay, of hazards that come and go. You might be working aloft, it's a nice sunny day, all of a sudden the ship changes course, shifts the wind, and now all of a sudden you're out you're blowing a hoolie, and and that could be an example. So the hoolie, the hoolie, the wind is the hazard. Okay, so all morning you've been chipping away, happy as a lark, and then all of a sudden the vessel changes course, and now all of a sudden the hazard that you considered in the morning that you've been so comfortable up there, and it just changes like that. So please keep that in mind, that hazards in a particular job may appear, may disappear, and they're constantly moving. So this is my second last slide here, guys. We're talking about barriers. And I know I've touched on barriers quite a bit. Barriers are controls, and I don't want to beat it to death, but there are three different types. There's active, passive, and procedural. And I'm going to discuss those in my next slide. And there's another diagram, I guess, to explain the Swiss cheese model and how it all works. Please keep in mind that no barrier itself is perfect, and therefore we try to put as many barriers in place to prevent an accident from happening. Okay, gang, this is my last slide for process safety. Before this lecture started, we used to talk about the Swiss cheese model, and really it represents the left-hand side of the bow tie model. And we always talked about the threats, and we always talked about trying to stop the event from happening. All right, risk assessments, barriers of control, Swiss cheese model, always having our barriers in place to stop the accident from happening. Okay, so in our changing the gasket scenario from this lecture, we had different barriers in place. We had toolbox talks, we had permit to work, we had plant isolation, and in our lecture here, we talked about the toolbox talk. And the toolbox talk, let's say in my example here, never talked about the proper material for the gasket, and it never talked about the inexperience. Let's give this guy a name. Let's call him Charlie. So the inexperience of Charlie when he's replacing this gasket and opening up the flange. Okay, so that's fine. So one of the hazards got by in the toolbox talk, but the permit to work system caught it, and poof, it didn't become a problem. But like I said, the toolbox, the permit to work system, the lockout for life system didn't address the inexperience of Charlie, and it didn't address the gasket material. So because of that, we put the wrong material in. Now, because of all the barriers in place, we did not hurt Charlie, right? It went out very, very well. We had policies, procedures. What else do we have in there? Chain blocking for lifting, all those different barriers, and no one got hurt. So from a simple Swiss cheese model and a specific job example, no one got hurt, and we would consider that a success. Okay, but we're not. Now we're looking at it as the entire process, and the entire process is of making sure the right material is in, the alignment of the pipe, so that it doesn't become a problem later on. Okay, so here, this whole model now is a bit more of an advanced Swiss cheese model, and this here is talking about the preventative barriers or controls, and here's the top event, and the top event is the leak starting from the failure of the gasket. And on this side, the right-hand side of the bow tie, is the mitigation barriers. So when this leak starts, and it starts to become worse and worse and worse, the consequences don't get worse and worse and worse, okay? So the leak starts, and the first barrier in place is doing our rounds or open reporting. And if we report that leak now, then poof, it stops right there. It becomes nothing. It doesn't get any worse than that, okay? But for whatever reason, we don't care. We're not doing our rounds. We don't open report. And that leak becomes a bigger leak. It becomes a spray. It hits a hot pipe, and it turns into a fire of some sort, all right? The next barrier of control is our firefighting system. And if our firefighting systems, our smoke detection, gas alarms, whatever it is, all play a part, and they sound off, everyone goes down, puts out the fire, and it's just a small fire at this stage, no catastrophic event. But like we said, if our barriers are imperfect, we don't have our alarms are gagged or whatever it is, they're not working properly, the maintenance on them is not well, and that barrier fails, that fire expands, and now all of a sudden, you have a major catastrophic incident, and poof, bad things really, really start to happen. So when we talk about preventative and mitigation barriers, the prevention barriers are all on the left-hand side of the bow tie, usually the standard good old Swiss cheese model. The mitigation barriers are on the right-hand side of the bow tie, and they are mitigating that small incident from getting bigger and bigger and bigger, and the consequences getting worse, worse, and worse. There's usually three types of barriers: active, passive, and procedural. Active and passive are usually hardware oriented. Active hardware might be something like a lockout for life or plant isolation system, where you actually physically do something with hardware. Passive might be something like fire alarms, gas alarms, stuff like that. So they don't do anything unless they're excited by the set-off material. And once they're set off, then they activate. Procedural is procedures. It could be something like the toolbox, not the toolbox talk, my apologies, like the permit to work system, that's a procedure. Working instructions of the piece of equipment itself, procedures within your SMS on how to operate a piece of equipment. All right. And guys, that is it. That is process safety for me. I hope you enjoyed it and you kind of understand it. And yeah, that's it, guys. Thank you very much.